Hello everybody. In this video, we are going to begin our lesson on friction. Let's imagine a scenario where a person is tasked with pulling a fridge across a surface, specifically a concrete surface. The person applies a force and finds that the fridge does not budge, and you might even say that the object was too heavy. What if we change the situation? We keep the same fridge and the person pulls with the same force, but this time we change the surface to ice. With the change of surface, moving the fridge is certainly more plausible. So what was the reason for the fridge not moving across concrete? This leads us to our first type of friction, static friction. Static friction force opposes the initial movement of an object and keeps the object still. This friction must be overcome before the object can move. There are a couple of specifics regarding static friction. There is the static friction force and maximum static friction force. The static friction force will always match the applied force to keep the object stationary. If the applied force is 11 newtons, the static friction force is also 11 newtons. If the applied force is 25 newtons, so is the static friction force. However, this does not go on forever. Depending on the object and surface material, there is a maximum static friction force threshold where the object begins to budge. For example, if the maximum static friction force is 50 newtons, it is when the applied force reaches 50 newtons that the object starts to budge. Lastly, to calculate the maximum static friction force, it's the coefficient of static friction times the normal force. The coefficient of friction is a ratio that describes how two bodies of particular materials interact while in physical contact with one another. Let's go back to the other scenario where we had the object slide across ice. The object is pulled on successfully, overcoming static friction and moving. Does this mean friction is gone and we don't have to think about it? The answer is no. After overcoming static friction, the object deals with kinetic friction, the force that opposes the movement of two surfaces that are in contact and are sliding over each other. To calculate kinetic friction force, it's the coefficient of kinetic friction times the normal force. There is one more friction I do want to mention, and it is called the drag force. The force exerted by a fluid on the object while it's moving through the fluid. Example of this would be the friction experienced going through water or air. Let's do a quick example on calculating maximum static friction force. A 24 kilogram crate initially at rest on a horizontal floor requires a 75 Newton horizontal force to set it in motion. Find the coefficient of static friction between the crate and the floor. To calculate the coefficient, we need to use this equation. We know the maximum static friction force as it indicates a horizontal force of 75 newtons gets the object to start moving. The normal force can be calculated by multiplying the mass by force of gravity. We can do this because force of gravity and normal force are equal and opposite in this problem. Since the normal force and maximum static friction force is known, the coefficient of static friction can be calculated, giving us 0.31. It should also be noted here that the coefficient of friction is a ratio and does not involve any units. Let's move on to the last example of this video. Alex attaches a rope to a 20.0 kilogram box of books. He pulls with a force of 90.0 newtons at an angle of 30.0 degrees. The coefficient of kinetic friction between the box and the sidewalk is 0.5. Find the acceleration of the box. We can begin by identifying the known information. The mass of the object is 20.0 kilograms. Alex pulls with a force of 90.0 newtons, and the coefficient of kinetic friction is 0.5. Find the acceleration of the box. To approach this problem, Newton's second law will have to be used. And to find the acceleration, the net force will need to be found first. All the forces need to be drawn and labeled to find the net force. There is the x and y force components of Alex. Those can be calculated using cosine and sine respectively, giving 77.9 newtons right and 45 newtons up. The force of gravity acting on the object can also be calculated by taking mass and multiplying it by gravity. There are two more forces that need to be calculated and labeled, normal force and kinetic friction force. The reason we're dealing with kinetic friction force and not static is because this object is moving in response to Alex's pull. However, since the kinetic friction force needs normal force to be calculated, the normal force will have to be taken care of first. To calculate the normal force, we need to recognize that there are only three forces acting on the object vertically: normal force, gravity, and the y component of Alex. These three forces make up the total forces in the y direction. And since there is no indication that the object is flying upwards or sinking through the ground, the net y force is 0. From here, the normal force can be calculated, giving an answer of 151 newtons up. Knowing the normal force, the kinetic friction force can be calculated by multiplying the coefficient of kinetic friction by normal force. And this gives us 75.5 newtons left. We're almost close to the end, since we identified all the forces. What is left now is to calculate the net force. The box of books is being pulled across the sidewalk, so it makes sense that the net force is only in the x direction. And there are only two forces in the x direction: the x component and friction. Combining those two forces will give us a net force of 2.4 newtons to the right. Lastly, the acceleration can be calculated by taking the net force of 2.4 newtons and dividing by a mass of 20.0 kilograms. The acceleration comes out to 0.12 meters per second squared to the right. This concludes the video on friction, and I hope you found it helpful. Thanks for watching.